Good morning. Today we'll discuss the topic of potentiometer. How is it possible to measure the internal resistance of this cell with the help of the potentiometer? Okay, so see here, using potentiometer we can measure the internal resistance of a cell. Okay, how is it possible to measure that value? That only we are going to discuss in this topic. This experiment we have in our practicals. So the concept of this experiment we'll discuss now. We'll do this experiment later in our lab. Okay. And one more thing I want to explain you. The potentiometer wire is made up of constantan or manganese, I told you. Why we choose these two materials alone to manufacture the wire of potentiometer? That reason you must know. That is a very important one mark question. So see here, it has a very low temperature coefficient of resistance. Here alpha is nothing but temperature coefficient of resistance. Okay. So when that value is very low, that time it is independent. That means the resistance of the wire is independent of the temperature. Okay. So the next one, they have a very high value of resistivity. The resistivity of those two wires are very high. Okay. So using these two materials, if we construct the potentiometer, that time that potentiometer is used to measure the accurate values. Okay, accurate value of EMF or accurate value of internal resistances can be calculated. That is independent of the temperature. The resistance of the wire is independent of the temperature. So our measurement will be very accurate. Okay, so see here. Already I told you that contain 4 meter to 10 meter long wire. The initial point of the potentiometer wire is taken as capital A and final point is taken as capital B, and that two ends are connected with a battery, key 1 and rheostat, with which we can provide the constant current that will flow through the potentiometer wire. So in this case we are going to measure the internal resistance of the cell, no? So see here, that cell is connected with the end A. The positive terminal of the cell is connected with the end A and the negative terminal is connected with the galvanometer, and other end of the galvanometer is connected with the jockey. See here, in this cell, the high resistance box, node resistance box as well as a key K2 also connected in parallel. See here, if this key is open means the EMF can be measured with the help of the balancing length AJ1. Okay. If this key closed means that will measure the potential difference, that become a closed circuit and that will measure the potential difference. Okay. So you remember. So initially the experiment நம்ம எப்படி பண்ணுவோம்னா K2 open condition ல வெச்சிட்டு, okay, that time will measure the balancing length. நான் ஏற்கனவே உங்களுக்கு இந்த balancing length எப்படி மெஷர் பண்ணனும்னு சொல்லிருக்கேன். இந்த கீயை வந்து slide over the wire at a particular length. The galvanometer shows null deflection, that is said to be balancing length. Okay. So see here, when the key K2 is in open condition, the balancing length, with the help of the balancing length, we can say the EMF like this. See here, K2 is open means the EMF of the cell is equal to KL1. What is K here? It is the potential gradient. Okay. And if K2 closed means, if K2 is closed means that EMF become the potential difference, which is equal to KL2. That time also we have to measure the balancing length. That balancing length is said to be L2, but K value remains the same. Okay, so இங்கேயும் K தான் யூஸ் பண்றோம், but balancing length இந்த இடத்துல L1, and here when K2 is closed, the balancing length is L2. Okay, that time we measure the potential drop. So see here, divide these two equations. E by V means K gets cancelled. So L1 by L2. This is the equation number 1. And already we know that what is E? That is equal to I into capital R plus small r. Okay. and V is equal to I into R according to Ohm's law. So divide these two expressions, E by V, that is equal to, we'll get these two. So I gets cancelled, that is equal to R divide பண்ணும்போது 1 ஆயிடும் plus small r by capital R. So what is E by V? According to this, E by V is equal to 1 plus R by capital R. Small r is here. It is the internal resistance of the cell that only we are going to measure here. What is capital R? That is the external resistance, and this is the equation number 2. External resistance will be measured with the help of the resistance box that can be chosen by us. So on the external resistance value நம்ம choose பண்ணிருப்போம். இந்த resistance box use பண்ணி நம்ம வந்து அதனோட value வந்து choose பண்ணிருப்போம். So அந்த value இங்க substitute பண்ணிக்கலாம். So see here equation number 1 and equation number 2. In these two equations the LHS are same. So we can equate the RHS. See here like this. I need the value of small r. So in the 1 equal symbol இந்த பக்கம் வரும்போது -1 ஆயிடுது. So what is small r here? That is equal to L1 minus L2 by L2 into capital R. So this is the expression for internal resistance of the cell. So see here, what is L1? That is the balancing length when K2 is in open condition. What is L2? That is the balancing length when K2 is in closed condition. And what is capital R? That is the external resistance that can be chosen with the help of the resistance box which is connected in parallel with the cell. Okay. So we know that all these values, so we can calculate the internal resistance of the cell. The internal resistance, what is the unit of internal resistance of the cell? That may be any resistance. The unit is same, that is ohm. Okay. So that's all about. This is the concept of potentiometer with which we can measure the internal resistance of the cell. That's all. If you have any doubt, you can ask me. Thank you.